So we're going to solve this problem, and I'm going to use Laplace for that. Nick just said, can we just do it with phasor? And I said, we can't. Phasor is only good if your source is sine or cosine. If your source is u sub t, because what we tell you here, u sub t, or 2u sub t is this source. It has a value of 0 for t less than 0, has a value of 2 for t greater than 0. That's what 2u sub t. So it's really equivalent to having a switch here where you have a 2-volt source here, 2-amp source with a switch. When t hits 0, the switch will close. And now you have current and voltage going through the circuit. So we can go back to circuit 1 when we learn circuit 1 and do it that way. But I think Laplace will not be a bad idea here. So the first thing, I'm going to change this to Laplace. In Laplace, the u sub t is 2u sub t is 2 over s. I should have took a picture of all the Laplace actually functions. I didn't take a picture of it. But here's what I took a picture of. So you need one of these. And this picture lets you know if your source or if your element is a resistor. When you go to Laplace, we keep it the same. If you have an inductor L and you want to find the voltage there, we make that inductor of SL with the voltage source. But if you try to find the current through that, because that's the integral, and the Laplace of the integral is 1 over S. So that's why you have 1 over SL plus I sub 0. Notice the direction of the voltage here. It's plus to minus, and the value is negative here, which means really negative to plus with that being positive here. I'm not sure why the book used negative here. I would have switched the sign, made minus on the top, plus on the bottom, and made that a positive. It's the same thing. But the reason, because the Laplace of the derivative is SL minus I sub 0. And this is the Laplace of the integral. When you have a capacitor with the value of C, remember, I equals C dV dt. I equals C dV dt, which means V equals, I'll just write it down here actually, next to this. For an inductor, V equals L di dt. So if you take the Laplace of that, here's the L. What's the Laplace of the derivative? S times I sub S minus I sub 0. So if you distribute that L through, you end up with SL I sub S minus L I sub 0 minus. And that's why that's the Laplace of that. You look at this, you go I equals C dV C dt. Again, the Laplace of that, as times, not equals, S times V, capital V as a function of S, minus the voltage is 0 minus. So that's what? SC times V minus what? C V0 minus. And notice that's the current. When you're adding current, they have to be in parallel to me. So that's why the value of this SC and the value of this, the current will be coming down, but notice I drew this one going up. That's why the minus sign to indicate the direction is backward. So the value, but if you want to find now the current here, it's 1 over L, the integral of V dt, and if you do the Laplace of that, right here. Oh, you have one there, huh? Yep. If you do the Laplace of that, you end up with this one. And this one, if you find the voltage, V equals 1 over C, the integral of I dt, and you take the Laplace of the integral, you end up with this one, 1 over SC. Oh, yep. Take one, yeah. So that's the reason why they have the two sets of equation. Are we looking for the voltage or the current? When you're adding voltages, it's always in series. When you're adding currents, it's always in parallel. That's why they're in parallel. If you're looking for the voltage, that's in series here. That's why these two. But if you do them for the current, They're going to be in parallel. So since that means I forgot to do one more thing or mention one more thing. What is my current through the inductor at 0 minus for this circuit? And what's the voltage across the capacitor at 0 minus in this case? Well, there is no source on the circuit for t less than 0. Your source was a 0. There's nothing going through it. So this is a 0, that is a 0. For this example. We'll change them soon. Now, here we go. If these guys are 0, that makes my life easy. I can replace the inductor with an inductor with the value of S of L, and this is 0, that's gone. And I can replace the capacitor with what? 1 over SC, and that's gone, because that's a 0. So if I do that, the resistor stays the same. The inductor is going to be S times L, which is what? 2 times S here. This source is going to be 2 over S. The resistor stays the same. The Laplace of R is still R. And the Laplace of the capacitor is 1 over SC. So that's 1 over S. C is 1. And this is still 2. And now this voltage here will be my voltage as a function of S. So if you remember, we said in Laplace, the first step, we're going to take the circuit from time domain, change it to S domain, which is Laplace. That's what we just did. We changed all the sources, all the elements to S domain. We're going to solve it in the S domain. Then we're going to change it back to time domain. So I can do 2 equations by 2 unknowns. It doesn't look like it's, oh, I can't, well, I could. This is I sub 1. This is I sub 2. Now remember, this is a current source. You could never do KVL right here or right here. Why? What is the voltage right there across that current source? We don't know. So that's a refresher now of circuits 1. So you really can't. You got to do the outside loop. Then I can say, well, the current going up, the 2 over S, that's the first equation. It's the current going up, right? The 2 over S is equal to what? Isn't that I sub 2 minus I sub 1? Based on the way I drew them. I sub 2 is pushing up. I sub 1 is pushing down. That's my equation 1. And now let's do a KVL on the outside. Outside of this. Negative 2 over S plus, this is 2S times I sub 1 plus 2 times I sub 2 plus 1 over S times I sub 1, I sub 2, sorry, plus 2 I sub 2 is equal to 0. I'm going on the outside. So this equation 1. Clean that one. I see 2S times I sub 1 plus 2 and 2, 4 plus 1 over S. So that's 4 plus 1 over S times I sub 2 is equal to 2 over S. And that's my equation number 2. I'm going to use what Joe told me last time, the TI-89. I can say simultaneous solve them. So let me go to the 89 instead of using algebra here. The math is really not bad here. I could have done it.
Could you possibly use a solve? I didn't know. You made the math way too hard, man.
Wait, Joe, which one the apps? I need to go, where is that?
I'm gonna do it with you. Just so
Let's see solver. Where is the solver? Can you see it?
it should be simultaneous.
Simultaneous or edit? Is that the Y?
No, go up.
Go
Yeah,
up.
because you have two equations. So you go to
This one, A, B?
simultaneous.
Yep.
Yep.
The simultaneous is two equations.
So you
by
go
two.
down to new,
New.
then you do
2 by 2.
2 by 2.
and if you press enter, it'll do it all for you.
Yeah, and it basically creates a matrix.
Okay.
And then you're just gonna have your S's in terms of X.
Okay. So that'd be -1. Oh, that's not the negative actually. That's a -1. I'm putting I sub 1 first. 1. 2 divided by x instead of s. I mean, I could put s. I can look for it, but who cares?
How do
That-
you solve this if you're bored? Have a calculator.
2x
You can use substitution.
plus.
Substitution.
Oh, there's no plus here. This will be 4 plus 1 over s, 1 divided by x. And the answer is 2 over s. 2 divided by x. And now where I go to solve it? What do I hit? What do I hit to solve it once you enter them?
F5.
F5? Wow, it's factored and everything.
So yeah, yesterday
Okay.
it was all factored out even on the bottom too.
Yep, well, I might have to clean that a little bit there. So here's what we found, that I sub 1 equals 2 times 2x plus 1 over 2x squared plus 4x plus the 1. I sub 2 times 2x plus 1 Did I get the same value for both? Did anyone try them too?
I'll try it.
See if you get the same answer for both of them. I got the same answer.
So it's -1, and then I2 is 1, and the answer is 2.
Assuming this is correct, V out as a function of S. Let's look at V out. Isn't that 2 times I sub 2? So I don't need to find what I sub 1. V out as a function of S.
Can I just see it?
V out as a function of S is equal to 2 times I sub 2, which is going to be 4 times 2x plus 1.
Yep.
Is it? I'm going to factor a 2 out of this in the bottom.
Is it X or S?
Huh?
It's S.
S, I'm sorry, I use X, I typed an X in place of it. That's S.
Actually, my top one for I1, I have a minus 2 actually.
I would erase that X on that.
Yeah, I'm going to put S's on them.
Because then you're gonna.
Yep, they're all S's, everything.
Yeah, I1 has a minus 2x in the denominator.
Minus here.
I got something different.
What about I sub 2?
I sub 2 is exactly what you got.
Good, that's all I care about. We have to use X, S's, I forgot, because I typed in with S there.
Minus 2x at the end for I1 is in the denominator or just like on the side?
It looks like it's in the denominator. Oh, wait, no, this is numerator, so.
Mr. Z?
It has
Yes.
all this stuff in
The
denominator.
denominator for
No, that would be
2 times I2,
Numerator.
it says plus 2s plus 0.5.
It looks like it's separate.
Yes,
Yeah, that makes sense.
Where did that 0.5 come from?
because I factor a 2 out.
Oh, okay.
I'm dividing each one of these by 2, so that's 1, 2, and that's a half. I don't care really about I sub 1, it's not an issue here.
I was just going to show you. There's a minus 2x
Let me
at
see.
the end. Minus 2 over x.
Oh, minus 2 over X. What is that?
Pretty sure it's by
Oh,
memory.
for I sub 1?
Yeah.
After that?
Yep.
Oh, that, I guess I didn't go that far. Yep. Yeah, I saw mine, I just didn't know there's an arrow there. Yeah, I guess there's an arrow to go farther, you're right. Right here, 2 over S left there, but I don't need I sub 1. So this is actually I sub 1, this is I sub 2, the correct answer, bless you. Now, if I was doing this, I can use a quadratic, and I probably will avoid using quadratic, because I can do it much easier. That would be what? I'm going to divide everything by 2. That would be 2 times 2s, which is, here we go, 2 times 2s plus 1 over s squared plus 2s plus 0.5. I factor a 2 out. In my plan, my thinking with this problem, I don't want to deal with the quadratic. Quadratic is not fun. So why can't I just factor this? It's not going to be a whole number, but who cares? If you solve that quadratic equation, you will have what? Minus 2 plus or minus, I'm solving the bottom here, the square root of 4 minus 4 times A times C, 4 times 1 times, that's a 2. Minus 2 plus or minus the square root of 2 divided by 2. So if you want to use decimal values, you can give that to be what? Minus 2 minus the square root, let me get out of this first, quit. I'm excited about learning solving quadratic here, actually. So I learned something new today. I got to get to my calculator now. Where's the calculator?
Just press home. There should be like a home.
Home button? Where's
right
the
underneath the green button.
home? Yes. Oh, good to know. See? You always learn something. So it's minus 2 minus the square root of 2. The greeter's out there. Escape. Divided by 2. And to get to a decimal value, I get negative 0.8535. How about 4? And the other one will be what? Minus 2 plus the square root of 2 divided by 2. And give me a decimal value. That's negative 0.146. Now watch how easy the problem becomes. I can write V out as a function of S to equal 2 times 2s plus 1 over, instead of leaving it like this in quadratic, make it S plus 0.854, S plus 0.146. Nobody said we have to have perfect numbers. Which you can break it down to K1 over S plus 0.854 plus K2 over S plus 0.146. And if I know K1, K2, I just solve for that as a function of S. Remember, the first step, change it to Laplace, solve it in Laplace. We almost done solving it in Laplace. I'm almost done with it. I just got to find K1, K2. And once I have that, what's the last step? Change everything back to time domain. So let me find K1, K2. K1 is sitting on top of S plus 0.854. So I'm going to take that out of the picture. So K1 is going to be my cheat sheet method, my shortcut method. When S equals what? Negative 0.854. Let's see if I can do the whole thing in one shot. 2 times, parentheses, 2 times negative 0.854 plus the 1, close parentheses, divided by parentheses, negative 0.854 plus 0.146, close parentheses. And I came out with exactly 2. K2. K2 is sitting on top of S plus 0.146. Take 0.146 out of that. When S equals what? Negative 0.146. Bless you. Again, let's do the same thing here. 2 times parentheses, 2 times negative 0.146 plus the 1, close parentheses, divided by open parentheses, negative 0.146 plus 0.854, close parentheses. And I got a 2 for that one too. It's like we planned it that way, huh? So V out as a function of S, now it's completely solved. It's K1, which is 2, divided by what? S plus 0.854 plus K2, which is 2 over S plus 0.146. So what do we do now? What's V out as a function of time? Inverse Laplace. What's the inverse Laplace of this? This will be 2 e to the power of negative what? 0.854t plus 2 e to the negative 0.146t, u sub t. Now the only thing could be wrong is me pushing the numbers on the calculator. But if, bless you, if I push all the right numbers, that's my answer. So you can look at that and see if we screwed up with the numbers. So in this case, I managed not to use the quadratic because I can factor that. Sometimes you can't really get rid of the square roots there. I mean, you can't factor that and get a real number. So we have to use the imaginary one in the method that we learned, 2 times k and all that stuff there. So let's take another example, make it a little bit bigger now. That's the voltage across the loss resistor. The question, what was the voltage right here?
I mean, do you actually write V? Do you have to write?
That's all I care about. What's the voltage as a function of time?
No, I'm saying, do you have to write V at the end of it or no?
Oh, voltage, you mean? You can say volts, yeah. Because that's the voltage. Yes.
We know that the complex domain is comprised of imaginary and real numbers.
Yes.
And then there's the time domain, which is what we usually use.
Mm-hmm.
Now, what is the S domain comprised of?
Now, S is the complex domain, which is real plus imaginary. That's what the S domain is.
Oh, it still is?
It is. That's what the S, when we say the S domain, that's the complex, you know. That's why S earlier, when we started talking about Laplace, we said S equals, has alpha plus j omega or j beta, whatever, as a real portion and imaginary portion. You know. Now, if alpha happens to be 0, just imaginary, you know, it could be that means alpha is 0. If you only have real value, that means the imaginary portion is 0. You can still use this, you know, even when you have real values only, or you have imaginary values only, because that means just change it to this one 0 or that one 0 to make it a complex number. 5 is not a complex number, but if you make it 5 plus j 0, it is a complex number.
So it sounds like it's pretty closely related to complex power.
Oh, you think about the complex power? Yep. I know where you're going with it, yep. Let's take, I know because we use S for complex power, but it's not really S. S is Laplace here.
They just seem like they're a lot related.
Let's take another one. And again, if we make the initial conditions really zero, like U sub t, it makes my life easier. Soon enough, I'll change them. But we'll start with the initial conditions today being zero. So here's another problem, a little bit bigger. Maybe we'll put a current source on the top. And that's 2U sub t. 2 is the popular number today. I stopped, got some gas, bought 2 Powerball tickets, 2 Mega Millions, so maybe 2 is my lucky number today. Just the good news, if I win, I'll finish this semester, guys, don't worry. I'll come give you a final exam.
Okay.
Because if I don't show up, they have to give you all A's. No.
Sounds like a good idea. You give us a couple million too, right?
I'm going to buy a large pizza.
It's okay, you don't need the A's, you can just give us a part of your check.
What about the large pizza I was planning on buying you?
Well, where are you buying it from? That's real
What
quick.
money can buy pizza?
Stick pizza.
God, no, that's come on now.
Come on, you can do better.
You're like a multi-millionaire at that point. Might as well buy something pretty crazy.
Okay, I'll go to Costco. They have them by the slices, cheaper.
Costco's pretty good.
You'd make a humble lottery winner. What are you gonna do with your millions of dollars? Oh, I'm gonna go to Costco.
Oh, so he's gonna be like crazy to become a millionaire.
Nobody will find me. I'll be good. My wife might not even find me. You know, I'll be gone. No. Okay. Now it's being recorded too, so you know my wife's probably gonna say she never watches this stuff, so don't worry. I'm safe.
Well, if you disappear, she'll listen to the last.
Yep.
video.
Unless somebody goes, I know where.
Of course, this is the one day she does. So
Yeah.
you come home and she's just waiting for you. Like, so I was watching something on YouTube.
Yep. So this is in time domain again. The good news, we have U sub t, which means for t less than 0, there was nothing going through the circuit. So the initial current through the inductor will be 0. The initial voltage across the capacitor will be 0.
That's when there's nothing after the use of the.
Yep, well, U sub, nothing after, because that's a U sub t. I mean, if they had one negative U sub t, that means backward, you know. Or if you have some initial condition, it was on for a while, and you came in, and 2 seconds later you turn the switch on, you know. Then you can say it's 0.
So if it was negative U sub t, it'd be like 1 volt?
U sub t will be the negative U sub t will be the reverse. I mean, U sub negative t, not negative U sub t. U sub negative t is the reverse, has a value of 1 for t up to 0, then 0 after that.
Okay, so those would be equal to 1 if it was that case.
Well, no, we'll have to look and see what the current will be. It doesn't have to be 1. The source will be a 4 here if that was U sub negative t. That would be a 4 for t less than 0. You have to find it. We'll do some, don't worry. It's coming up. So my initial condition is 0, so I can drop these out. So here we go. This will be 2 over S. The resistor stays the same. The source is going to be changed to 4 over S. Is this a resistor? I think that's a resistor there, right? I drew there. I can't even read my handwriting. 1 over SC. 1 over SC. Is that 2 over S? And this is SL 1S. It looks like we have 3 equations by 3 unknowns, but it's not. We already know one of the currents. Which one? Yep, the top one, 2 over S. That's 2 over S. So you only have 2 equations by 2 unknowns. This is I sub 1. This is I sub 2. So let's do KVL right here.
What is a capacitor?
1 over SC. And the inductor SL. And that's coming from this sheet. Capacitor 1 over SC, the inductor SL, if I'm looking for the voltages. If I'm looking for the current, I'll change that. So now let's do the first mesh right here. That's negative 4 over S plus that resistor 2. What's the current through that resistor? I sub 1 minus what? 2 over S. This minus that. Plus, this is 1. What's the current through that? I sub 1 minus I sub 2. When you multiply the 2 times negative 2 over S, what are you going to have? Negative 4 over S, and you have negative 4 over S. When you add them, what are you going to have? Do you see it? Negative 8 over S, everyone? So if I take it to that side, it becomes 8 over S. I get 2I sub 1 plus 1, that's 3I sub 1 minus I sub 2. That's my first equation, if we did the math correctly.
That's the KVL, I will make.
KVL loop 1, yep. KVL number 1. That's this one. Now let's do KVL for number 2. That's this one. Let's begin with that, the inductor here. Easier to start with this one. That'll be what? S times I sub 2 plus 1 times what? I sub 2 minus I sub 1. And plus 2S, or 2 over S, times the current through that, which is I sub 2 minus 2 over S. That's 4 over S squared when you multiply it. And if you take it to the right side, it'll be 4 over S squared equals. Let's look at I sub 1. We have negative 1. What is I sub 2? 1 plus S plus what? 2 over S? Again, thank goodness for the 89.
Yeah.
Maybe now TI will call me and give me some money for trying to sell their calculator. I'm actually a huge
You don't
fan.
even need any money. I mean, it's
Yep.
$100 calculators.
Actually, I saw the price is down. I just bought 2 more of them.
I was gonna say I got this one used for $8.
I bought 2 yesterday from WB Mason for 109.
I got this
Brand
off-
new. Yep.
See, I got this off.
No. I just need to buy 2 because I lose them every semester. Yep. Go ahead, Joe.
I got this one off Amazon, and I think it came from probably Japan because the batteries are like cartoon characters from Japan.
109. I bought them. Each one is 109. Each one is 109.
I
Yeah.
saw this one. Gotta go home and use.
I was
So-
like, I got this one, it was slightly used, it's really not that, like, bad.
Okay. 2 by 2. Here we go. I'm going to use what Joe told me. 3. Negative 1. I could actually use S. I just got to find where the S key on this. For those people who want to use S. Because it has all the alphabets on it. Where's the S key? Does anyone see it?
Yeah, it's where the 3 is. You have to do alpha and then.
Oh, never mind, too much work. Yep.
I know, I was just.
I'll just use x and I'll just change it to s at the end. 8 over x,
Oh my god. You're not gonna like this one,
no?
probably not.
And the other one is negative 1. 1 plus x plus 2 over x. And the answer is 4 over x squared. And F5 to solve it. And it's taking a while. Here we go. I sub 1 is equal to. Uh-oh.
Shouldn't the 2 over x be in parentheses? Can you put it in?
No, it goes in that location here.
Okay.
There's a block there for it. It's 4 times. Again, you can double check these. 2x squared plus 2x. Oh, s. This is x, Mike, but we're using s here. Plus 2s plus the 5, all divided by s times 3s squared plus 2s plus the 6. Let me know if you get the same answer.
Yep.
And I sub 2 is equal to 4 times 2s plus 3, I think, over s times 3s squared plus 2s plus the 6. It's not that bad, actually. But before I get to that, while I'm here, I'm looking for V out. Notice plus on the top, minus on the bottom.
So
Right?
subtract those two terms,
Subtract and multiply by 1.
and then solve.
V out equals 1 times I sub 1 minus I sub 2. While I get these numbers, I might be able just to go grab them on the 89 and subtract them. I don't know if it'll allow me to do it or not without having to exit this, because I'm in the solve mode. Unless I type the whole thing.
You could store them in the registers as well, it might be easier.
Oh, I didn't get that far. How do you do that?
You just do stow, the stow button, and then into.
Store?
STO, and then press.
Where is that? STO.
Should be,
Oh, I see it. STO here.
yeah. And
So
then-
I'll go to the first one, STO.
And then into the X, whatever register you want.
So just write X.
I can't really see the screen.
Variable.
I don't know if it's the same way as in that screen as if you do it in the home. I haven't tried it.
I'm just doing it at home right now.
What, does it bring the answers with it when you go to home?
Yeah, so if you're on that thing and then you click stow, the stow button now that you're highlighted over it, and then do into X, stow, and then X. It should do an arrow.
Wait. Still,
And then X.
but it knows which one?
As long as you're highlighted over the equation, it should.
I don't think I highlighted. And to go back to that equation to get the second number, how would I go back? I can type it, I mean, I can clear F1, 8. I'm gonna have to get another lesson on that. Set it to I sub 1 minus I sub 2. I'm sure if I type these the way I see them there, this will simplify it for me. Here we go. 4 times, parentheses, 2x squared plus 2x plus the 5
I got something.
divided by x times, well, I should do double parentheses here,
Oh, this makes it really clean.
x times parentheses 3x squared. Oh, wait a minute, just pure subtraction. The bottom is the same, right? I don't even need a calculator for that.
No, I don't.
So that's equal to what? The bottom will be S times, we're getting dependence on these calculators. So 4 times 2, that's what? 8S squared. 4 times 2S, 8S, minus 8S. See, 4 times 2, that's 8. So the S is gone. What's 4 times 5? 20. 20 minus 4 times 12, which is what? 8? Is that what you got there? Because the bottom is the same. So that's V out as a function of S. Now, if you decided to factor the 3 out of these, the bottom here, I'm not a fan of 3's. Because what we need to do next, I want S squared to be positive, 1. Here's the S. I'm factoring the 3 out of this. This will be S squared plus, what's 2 divided by 3? 0.67? 2 over 3. 67 roughly. 6 divided by 3, that's a 2. I can see that's a negative. If you plug into a quadratic equation, b squared minus 4ac, that's a negative number. So I'm going to have a complex root. So I got to find what the answers to these. Minus 0.67 plus or minus the square root 0.67 squared minus 4 times 1 times 2 all divided by 2a, which is 2. This will be a j here. 8 minus 0.67 squared keep on going with it. What's the square root of that? Oh, and I got negative 0.67 plus or minus 1.65, I don't know, 78. How about 658? I'm not going to carry all these. J divided by 2. So we have two solutions. One of them will be minus 0.4144J. There's something in the front, I just didn't do it yet. This will be plus 0.4144J. And what's 0.67 divided by 2? 0.335. So now I can write V out as a function of S as, bless you, I can make that 8 over 3 on the top. S squared plus 8 over 3. I'm dividing by 3 to get rid of the 3 in the bottom. I don't like it in the bottom. In the bottom, S times, this will be S minus, oh, that was a minus here, right? That'll be a plus 0.335 minus 0.4144J. The other one, S plus 0.335 plus 0.4144J. Which means you can write that as K1 over S plus K2 over S plus 0.335 minus 0.4144J. And the other one will be the K2 conjugate. Remember when you have complex quadratic? And if I know K1, K2, I'm done. That's what's in the way, that's it.
When you factor out the 8 from the top numerator, you get s squared plus 1, right? And then you have the 8 in the numerator, the 3 in the denominator. Can you just take that out as 8 over 3 and just leave that alone?
I could put 8 over 3 in the front, yeah.
And then
S squared plus 1. You could.
instead of having 8 over 3 s squared plus 8 over 3
Yeah.
numerator,
You can factor 8 over 3 out, sure. Make a
I don't know
difference.
if it'd be like more simple.
If you have a calc, that doesn't really make a difference. I'm going to type them in. 8 over 3, boom.
Yeah.
Plug it in. Now, to get what K1 is, notice K1 is sitting on top of S. So again, I'm not done solving in Laplace. I got to solve it in Laplace. I got to find K1, K2. I don't even know where my pages are. They're all over now. So to get K1 is sitting on top of S, take S out of that. So you want to take 8 over 3 out. S squared plus 1, leave it like that. Over, take the S out. S plus 0.335 minus 0.4144J. S plus 0.335 plus 0.4144J. When S equals what? What makes this one 0? 0. So I have 8 over 3 on the top. Let's look at the bottom. S is 0. So what's 0.335 minus 0.414I? Where's the I here? Where'd you go, I? Is it over 9? No, that's not an I. That's something else. I see over catalog. Times 0.335 plus 0.4144I. I'm not sure I get that crazy answer. Because this is this over this. If S is 0, right? I'm taking this S out. It's going to be 8 over 6. So if I factor this correctly, it doesn't seem like I factor it correctly. Because this piece here is that piece, right? And if S is 0, so K1 really, it's 8S squared divided by 8 over 3 times S squared plus 0.67S plus the 2 when S equals to 0. I don't know why I did it the other way. Just go back to this one. And in that case would be what? 8 over 6, which is what? 4/3? S is 0. No, when you find K1, K1 is sitting on top of S, right? You take the S out of that expression. Now for K2, to find K2, I'm going to take this piece out, which is sitting on top of this. So what is K2 is going to be? Again, if you want to leave it in that, the 3 here instead of fraction, you don't like the fraction there, so I'll leave it. Over S times, but instead of putting now this piece is out, just leave that piece in. That's it. When S equals what? What makes K, the bottom of K2 0? When it's negative 0.335 plus 0.4144J. And now we just got to use our dependable calculator here. Come on, calculator, help us there. Eight times negative 0.335 plus 0.4144, square that, close that, to the power of 2, plus the 8, divide the answer by parentheses, negative 0.335 plus 0.4144J. Uh-oh. Oh, you know what? I never put the J here when I did it for the top. Wait. I gotta go back to the top. I forgot to hit the I. 8 times 0.335 plus 0.4144I. I keep hitting that green button instead of the blue one. Square it. Plus the 8. I'm getting headache just typing these numbers. Take that answer, divide it by now, parentheses, negative 0.335 plus 0.4144I times another parentheses. Now when you S equals, this number will disappear, will be twice that number. Will be 0.8288I. Close. It's busy. As a decimal number, I came up with 40.2205, angle negative 61.5 degrees.
Were you missing that 3 in the denominator?
Yes. So divided by 3. That will make it, how can 40 divided by 3 end up being 3? I said divide that by 3, the answer. And it gave me 4.5. Let me see what that number was, just to see it. Clear. That was that number. Every time I get a different answer, I get 13.4 now.
Yeah.
13.4.
Yep.
And you divide it by 3 is what? Is that the 13 with the when you divide it or before?
That's after you divide it.
After you divide it?
Yeah.
You sure?
Yep.
Okay. 13.4068, right? Roughly. So after you divide, that's what the answer. So now I'm done. One more step. We said solve in Laplace. We just did. Now change it back to time domain. Let me go back here. V out as a function of time. What's the inverse Laplace of K1 over S? K1 is what? We solve for K1, that's 8 over 3.
4/3.
4 over 3, yep, 8 over 6, or 4 over 3, yep. 8 over 6. U sub t, the inverse Laplace of S is U sub t. Plus, now the inverse Laplace of this is a quadratic one, is going to be 2 times 13.4068 e to the minus alpha. Alpha is 0.335t. Cosine beta 0.4144t minus, and this one is what, 61 degrees? I really should change it to radian because that's in radian. You know? So I should take the 61, but I'll put 61.5 degrees. Just I'll put degree here to let you know your answer in degrees here. Again, it is possible that I made a math error there. I won't say I didn't make one. 4 over 3 plus 2 times 13 is 26.8 roughly. E to the minus 0.33t cosine 0.4144t minus the 61.5 degrees. U sub t. Matthew, you have the Mathematica. We should did Mathematica. Made it easy on us.
Did you want to change that to radians, or you said that just?
I'm just putting a circle over it to let you know that's in degrees. So if you're doing some calculation, you know, make sure you switch that if you want to switch it, you know.
Okay.
But I made sure that's in degree. This is in radian, really. So that's the answer to that problem.
That's crazy.
They weren't bad either one, because I made the initial condition 0.
Right.
Now, if your initial condition is not 0, then we're talking about more challenging problems.
Is that when you're adding in the other parts?
That's when you come in exactly. That's when you have to go, okay, what's my initial condition? Do I want to go with this or do I want to go with that? Which one of these design make my circuit easier? And you'll see me do that based on the circuit that's given to me. I can't tell you to do this now because I might be able to simplify them. If I have 5 things in parallel and I have an inductor, it would be crazy to put this one in. Why not put that one in? If I have things in series, maybe I want to put this one in. And the same thing with this one. I'll stop the